Hi guys, so problem 2 says the figure shows a collision between two pucks on an air hockey table. Puck A has a mass of 25 grams and is initially moving along the positive x-axis with a speed of 5.5 meters per second. It collides with puck B, which has a mass of 50 grams and is initially at rest. After the collision, the two pucks fly apart, with puck B traveling at a speed of 2.0 meters per second, traveling at an angle beta, which is 37 degrees below the x-axis. So the question is asking us the final speed of A and its final direction, alpha. And the first thing we need to ask ourselves when solving this problem is, what type of collision is taking place? Because when we know that, we'll know what is being conserved. So here, as you can see through the diagram, once the two collide, they separate apart, and this is a characteristic of inelastic collision. And so knowing that this collision is inelastic, we're able to know for sure that momentum is conserved, and momentum only is conserved. So because we know that momentum is conserved for this problem, we're going to go ahead and use the conservation of momentum equation. We're also going to go ahead and list out everything that we know about the two pucks in this problem so that it'll be easier for us to plug it in later when we have our equations solidified. I've written down all the information given in the problem. We were given the mass of puck A, the velocity or the initial velocity of puck A, the initial velocity of puck B, and the final velocity of puck B, as well as the mass. However, we first have to take into account that this is a 2D collision, so motion is happening on both the vertical and horizontal axes. And so for this reason, we're going to split up each puck into the X and Y components. Y So after we split the pucks into their respective components, we're going to want to use those components to plug in for the conservation of momentum equation in order for us to start trying to solve for alpha. Now that we've plugged all the values into the equation and gotten a value for each of the components, we're going to divide the velocity of puck A sine of alpha over the velocity of puck A cosine of alpha in order for us to get tangent alpha, which we can then take the inverse tangent of in order to find the true value of alpha. So now that we found our value for alpha, we're going to plug alpha back into either of the equations that we got for the velocity of the x component or the y component. So I'm going to choose the velocity of the y component, so BA sine alpha, and plug that back in and divide it by sine alpha in order for me to get the velocity of A. Finally, you just divide the velocity of sine times sine alpha by sine alpha in order to isolate the velocity. And you get around 3.33 meters per second.